Good evening, and my name is Kalini Jilanya, and I'm going to solve this problem situation related to normal distribution. So the problem is, or the given is, 2,500 senior high school students took an IQ test. It was found out that the mean score is 90, with a standard deviation of 10. Assume that the distribution is normally distributed. Okay, so first we need to make our own bell curve using using with what we have. So in here, I already drew it up. So the mean would obviously be in the center, which is 90, and then we're going to add 10 because it's been because it has a standard deviation of 10, which on the area to the right it would be 100, 110, 120, and to the left we're just going to subtract it to 90, which would be 80, 70, and 60. Next, we're going to divide it. So between 80 and 100, we would divide it to like 34 on each side. So 34 here between 80 and 90, and 34 between 90 and 100. And then for 70 to 80, it would be 13.5. Same to the other side, 100 and 110, it would be 13.5. And then 60 to 70 would be 2.35. And so as 110 and 120. The remaining parts of the bell curve would be 0.15 on each side. Okay, so now that we have our bell curve, we're going to tackle our first following questions. So, what is the probability that the IQ score is greater than 115? So, it is going to look like this. P x is less than or equal to 115, since 115 is greater, is equal to 1.175% plus 0.15%. Now, we're not using 2.35% because 115 is between 110 and 120, and we really can't use it because 110 isn't really 115. So in order to do that, 115 is located between 120 and 110. So what we're going to do is going to split up 2.35 or divide it by 2, which would make it 1.175. And that would be equals to 1.325% or 0.01325. So the probability that the IQ score would be greater than 115 would be 1.325%. Now, next question. What is the probability that the IQ score is less than 60? So again, we would write this. We write like this: X is greater or equal to 60, since 60 is lower than X. So when we look here, it says less than 60. So in here, in the bell curve, we can see that this is 60. The one that's lower than 60 would be everything to its left, which is 0.15, and that would be our answer, 0.15% or 0.0015. That would be the probability that the IQ score is less than 60. Number 3. What is the probability that the IQ score is between 85 and 105? So we would write it like this: P, and then 85 is less than X, but X is less than 105, since it's between 85 and 105. So in here, as we can see again, there is no 85 or 105 that you can see. But then again, we can always like split it up, since it's always found in between 80 and 90, and 105 is found between 100 and 110. So if we split that up again, you would get 17%, since that is the half for the 34. 17% plus 34%, because of here between 90 and 100, and then again plus 6.75, since that is the that is the quotient we get when we divide 13.5 with 2, and that would give us the answer of 57.75%, or 0.5775, and that would be the probability that the IQ score would be between 85 and 105. Fourth question: what is the IQ score located at the 86th percentile? So in here we are given that the percentile is 86. Percentile 86. We have to convert it to the area, to its area to the left, which would make it 0.86. Now we need to find the area to the left and convert it to the z-score. So we have to find something that's close to 0.86, and the one that's close to 0.86 is the z-score of 1.08, and the area to the left is 0.8559. Oh wait, no, 8599. So in order to get the percentile, we would use it in here. So the mean. Oh wait, no. Mean plus the z-score times the standard deviation, which would be 90 plus the z-score of 1.08 times the standard deviation of 10, which would give us our 86th percentile, which is 100.8. Now for the final question: how many students got an IQ score between 80 and 120? So again, we're gonna use the P. 80 is less than, X is less than 120. So we're going to get everything in between 80 and 120. So as you can see, this is 80, this is 120. So everything between it, we need to get the percentage of. So it would be 34% plus 34% plus 13.5% plus 2.35%, which would give us 84% or 0.84. But then we're looking for the amount of students who got the IQ score of 80 and 120. We simply got the probability. So in order to do that, we need to multiply the probability with 2,500. So 2,500 times 2.84, and that would be 2,100. So there are 2,100 students who got an IQ score between 80 and 120. That is all for normal distribution, and thank you for watching.